Hi, I'm Adrian, a senior here at Temple studying kinesiology.
And I'm Haleigh, a grad student here at Temple studying forensic chemistry.
And this is Fun Science Network. Science is everywhere, from the air we breathe to the ground we walk on. Today we're going to be talking about the complex processes happening under our feet right now, and how they influence many of the natural disasters that we hear about in the news.
Disasters such as Japan's 2011 earthquake and tsunami, as well as Iceland's 2011 volcanic eruption, can both be understood better when tied back to some very simple concepts regarding the composition of the Earth.
At the foundation of everything, we have to understand that the Earth is composed of three distinct layers: the crust, which sits on the top, the mantle, which sits in the middle, and an extremely hot core at the center of everything.
This heat radiates through the entire Earth and affects everything above it. In order for this to make some more sense, Jared will be giving us a demo.
Hi, I'm Jared. Welcome to Fun Science Demos. The big idea today is that heat moves matter. Heat moves matter in this lamp, and heat moves matter in our Earth. So let's take a look at this lamp and see heat move matter. You can't see it, but there's a light bulb here, and it's hot. It gives off lots of heat, and that heat heats up this purple wax. You can see it. Woo! It causes it to rise to the top. When that wax gets hot, it rises to the top. And you can see some of the wax dropping down. Why? Well, as the heated wax moves to the top, it just hangs out there, and it's cooling off. And when it cools off, it drops. It drops back down, and when it drops back down, it gets heated back up and moves up. And it cools off and moves down, and it gets heated up and it moves up, and it cools off and it moves down. It's this cycle. It's happening in the lamp. And wouldn't you know, the same thing happens in our Earth. So let's take a look at this diagram and see how the Earth works. Through science, we've discovered that the middle of the Earth is really, really hot. We've also discovered that the outside of the Earth has this crust. And the moving matter inside the Earth can actually move the crust. As it's heated up, it rises up to the crust. It cools off and comes back down. Just like this lamp, the wax in this lamp, it's happening inside of our Earth. The heat from the middle of the Earth is causing all this matter to move, and that makes the crust move. So let's take a look at that crust and the outside of the Earth. These are continents. That's where we live. The blue is the ocean. Oceans and continents actually sit on top of the crust. Well, what are these lines? Through science, we've discovered that the crust is actually broken into plates, and those plates move. Heat moves matter. Let's try and show you how that works. We have a heat source here. We have a heat source here. We have a heat source here. Our heat source is the middle part of the Earth. We need something to be the matter that heat energy can move around. We have our milk, and now we need something to be the crust. For that, we're using chocolate powder. So here's our setup. We modeled it after our Earth. We have our center hot part. There's the heat source down there making it hot. We have our crust, which you can see on the top. It's smooth right now. Something should happen as the matter, which you can't see, the milk, starts moving inside from the heat. Heat heats it up, rises, cools off, and sinks. There's movement happening. You can't see it yet. Let's zoom in and take a closer look. So our timer's going. Let's take a look at this setup and see what's going on here. Inside the pot, we have our liquid matter, much like the Earth. And we're heating that liquid matter, much like the Earth. And you can see the chocolate powder on top is our crust. It doesn't look like much is happening, but there's a lot going on underneath the crust, just like our Earth. So we're going to zoom in and take a closer look. But what should you be looking for? Well, that liquid matter under the crust is moving. It doesn't look like anything's happening to the crust, but as the liquid matter of the crust moves, the crust will start to move, and you'll actually see tiny cracks form, and those cracks will get bigger as the crust moves. So we're coming up on the 14 minutes, and now we can see our crust starting to crack. Why is that happening? Well, that liquid matter, we heated it up, and it's starting to move underneath the crust. And you can see that crust, they're called plates. Scientists call those plates, and they're starting to move. Look at this one right here. Seeing it start to separate? Take a look at these plates as they move. Why are they moving? The liquid matter underneath is moving too. Take a look right here and right here. Tiny cracks in the crust. The plates are gonna start to move, and you'll see the cracks get bigger. Watch right here. Watch it open up. Watch right here and right here. Ooh, there's one forming right here. Now we have a crack forming here. The crust is breaking in the plates right before our eyes. Why is that happening? The liquid matter underneath the crust is moving. Now we can start to see it happen. You can see the plate movements. As that liquid matter heats up, the crust, the plates move. Cracks are forming. We're at about 15 minutes in, and now we can see our plates really forming up here beautifully. We want you to remember that our continents and oceans actually sit on these different plates. I'm not putting them in the right order, but that's all right. You get the picture. Each continent and ocean sits on different plates, and you can see how the plates are separate by the cracks. What causes it? The moving matter underneath the crust. We can't see it, but through this demonstration, now we can. It's so easy to see the movement of the crust. Well, scientists call that movement of the Earth's crust plate tectonics. It's a big word, but so many cool things happen because of that word. Because the crust moves and those plates move, we have earthquakes, we have volcanoes, and even it forms new mountains. Science is so cool.
Thank you, Jared. So now that we have a foundation that the continents and oceans lay on top of plates and are constantly moving, we have a basis to move forward with in understanding many disasters. One such disaster is earthquakes.
In March 2011, a magnitude 9 earthquake hit Japan and caused a tsunami that devastated the whole country and left thousands homeless. What caused this to happen in the first place? What even is an earthquake? In order to understand this, Jared will be giving us a demo.
Hi, I'm Jared. Welcome to Fun Science Demos. This should look familiar. It's our home. It's the planet Earth, or it's a model of the planet Earth. And it shows us what we see. We see continents, we see oceans. It shows us that the Earth spins. But there's one thing that this model can't show us. It can't show us what's on the inside of the Earth. I press on this, and it's hollow. But through science, we've discovered that the Earth is not hollow. Through science, we've discovered what's inside the Earth. So what is inside the Earth? Well, when I look at my model, I see continents and ocean. But what you can't see is underneath the continents and ocean is a crust that covers the whole Earth. And underneath the crust is a warmer layer called the mantle. And then underneath the mantle is this hot inner core right at the center. So let's take a closer look inside the Earth. Underneath all the continents and the ocean, there's the crust. And it's important to remember that the crust is actually broken into pieces or plates. It's not just one. There's many pieces or plates. Through science, we've discovered that all those pieces and plates actually move. Now, in another video, we talked about why those plates move. Today, we want to talk about what happens when those plates move. So we're going to zoom in and take a closer look so you can see what happens when those plates move. But to do that, to show you that, we're going to use spray cheese to actually be the mantle right under the crust. And then we're going to use graham crackers to be the crust. It's important to remember that this mantle is hot and parts of the mantle are moving. And then we have the crust. The crust sits on top of the mantle in pieces or plates. And because parts of the mantle are moving, that means parts of my crust are moving. And that's what we want to look at. Remember that continents and oceans are sitting on top of this crust. And those plates are moving. And one way those plates can move is those plates can actually move apart. When they move apart, that mantle actually forms new crust. And when the plates move apart, this is happening under the ocean. Actually, new crust is added as those plates move apart. And right here, as the plates move apart, the mantle cools down and it forms new crust. So we've seen that plates can actually move apart, but let's take a closer look at what happens when plates slide past each other. Okay, so we've zoomed in so we can take a closer look at what happens when the plates slide past each other. Watch what happens as I slide the plates past each other. It's important to remember it's not a smooth ride. It's actually quite bumpy. In fact, that bumpy ride as plates slide past each other, that's what creates earthquakes. So we've talked about what happens when plates move apart and what happens when plates move past each other. Well, what happens when plates bump into each other? So we've zoomed in again to see what happens when one plate collides with another. What happens is when the plates come together and collide, one plate goes under and the other plate stays on top. Take a look at that plate that's going under the other one. That plate will actually melt because it's so hot in the mantle. So far we've taken a look at what happens to the crust when the plates move under the ocean. But what happens when those plates move and there's a continent on top of the crust? Okay, we've zoomed in. We have our mantle, we have our crust. Let's add some continents. What happens when the plates move together and collide when there's a continent on top? Well, watch what happens. As the plates collide, the continents collide, and I'm going to push, and what do you see happening? So what is that? What did we just make? Well, actually, this is the way moving plates make mountains. The Earth is an amazing place. It's always changing because those plates are moving. Those moving plates make earthquakes happen, they make mountains, they even make volcanoes.
So, as Jared explained, an earthquake is a result of two tectonic plates sliding together. In the case of the earthquake that hit Japan in 2011, the Pacific plate, which lies under the majority of the Pacific Ocean, slid against the Eurasian plate, which lies under most of Europe and Asia.
This caused a violent earthquake, but also a massive tsunami that devastated much of Japan.
Wait, did you say it caused the tsunami?
Yes, I did. And to explain that further, Jared is going to do a demo.
Hi, I'm Jared. Welcome to Fun Science Demos. In the previous video, we talked about how earthquakes happen. But with this demo, we want to talk about what happens when an earthquake happens under the ocean. To do that, we used a rain gutter to hold our ocean and a small section of rain gutter to be another plate that's going to shift or move to cause our earthquake so we can see what happens. And we also have to build our beach right here. So we're going to finish adding some sand to where it meets the ocean, smooth it out a little bit, and our beach is ready to go. Remember that under our ocean, the crust of the earth is made of plates, and those plates move. They can move up and down, they can move side to side. And sometimes when those plates move under the ocean, it can create an earthquake. And sometimes that earthquake can start a big wave that scientists call a tsunami. I'm going to start by putting my hand in the water, and that's going to act as a plate. I'm going to move my hand just a little bit, almost like an earthquake, and I want you to watch what happens to the water. What did you see? Well, I saw a wave go toward the beach. So when the plates move, what happens to the water? Well, we put energy into that water, and that energy moved through the water in a wave. Now that was a small wave, but what happens when two plates move suddenly? An earthquake will create a bigger wave. Let's see if we can make that happen. Here we go. So now we take the smaller section. This is going to be one of our plates. We're going to put the plates together by setting it into the water. And now let's see if we can make a smaller tsunami. I have to make the plates shift. Here we go. And one rolls at you. Let's see if we can do that again and make a second wave. And watch that tsunami roll towards you. Here we go. Getting ready to shift the plate. There's that wave rolling at the beach, and it rolls up. Remember, these are just small plates, but under the ocean, the plates are really big, and they're under a lot of pressure, and when they move, a lot of energy is put into the ocean, and that energy can create some really big waves that can do a lot of damage. Remember, when plates move, they can create mountains, they can create volcanoes, they can create earthquakes, and they can also create a tsunami.
Thanks, Jared. So, the tsunami in Japan was a result of water displacement caused by two plates sliding together.
In particular, a part of the specific plate moved about 164 feet southeast and about 33 feet upwards.
This may not seem like a whole lot of distance when thinking about the scale of the earthquake, but then you have to understand that this was a 190 mile by 90 mile chunk of plate that did this.
The result was a massive series of waves that rushed outwards from the epicenter at close to 500 miles per hour and reached the Japanese coast within 1 hour.
Disasters like this, though difficult to predict, can at least be better forecasted by understanding the science behind the mechanisms that underlie them.
One example where this is very true is in the case of volcanoes. In the case of the Mount St. Helens eruption, volcanologists were able to predict the eruption months in advance and evacuate just about everybody from the surrounding area.
In order to understand how they predicted this, we first need to understand what a volcano actually is.
Hi, I'm Jared. Welcome to Fun Science Demos. Through science, we've discovered that inside the Earth is really hot. It's so hot that it can melt even rocks. And when those rocks melt, it becomes a liquid. And scientists call that liquid magma. And sometimes that heated magma breaks through the crust of the Earth. And scientists call that a volcano. We're going to make a volcano today to show you how that volcano works. Now for magma, that hot melted rock, we're going to use chocolate syrup. And that's just below the crust. Scientists call that the mantle. Then we need our crust. So I'm going to put this plate and this bowl. And to make up our crust, I'm going to use ice cream. Just scoop it in. So we have our magma chocolate syrup and we have our ice cream crust. Now this magma is under a lot of pressure. And to demonstrate that pressure, I'm going to squeeze that chocolate syrup and see if we can get that magma chocolate syrup to break through the crust of the ice cream, the surface of the ice cream, and see if we can actually form a little edible volcano. So here we go. Let's see if we can make our volcano erupt. Putting pressure up, and we have magma flowing. Put more pressure on. You can see it's just oozing out. A gentle, slow flow. Stop the eruption. Now there's a couple things to notice here. When that magma broke through the surface of the crust, it cooled down. Look. It cooled down and became hard. That's exactly what happens in real volcanoes. Magma breaks through the surface of the crust and oozes down, and it becomes hard. Also notice where the magma broke through the surface of the crust. There's a big hole, and scientists call that a crater. And when this volcano erupts again, it'll form another layer of magma, making the volcano grow bigger. See if we can get it to erupt again, and another eruption. Now only some volcanoes actually ooze magma slowly. Other volcanoes actually explode, and scientists call that an eruption. And sometimes that magma or liquid rock is under a lot of pressure, and it actually causes the volcano to explode or erupt. Now to demonstrate that, we have air that's under a lot of pressure, and we're going to see if we can make our volcano explode or erupt. And pay attention to the magma. See if you can see the magma shooting out through the crust. It doesn't ooze this time. We're going to see if we can launch it or explode it up. Now things could get messy, so I came prepared. Here we go. See if we can make it erupt. Yep, our volcano is definitely erupting. Remember, a lot of pressure builds up, causing the magma to come shooting out or erupting out of the volcano. It's quite a mess, but the good thing is, I can eat it. If you want to learn more about how the Earth works, check out our other videos or links in the video description. Science is so cool, especially when it's messy. Thanks for watching. Yeah, our volcano is definitely erupting. In a previous video, we used ice cream and chocolate syrup to show you how a volcano works on the outside. Now it's time to take a closer look at what's going on inside a volcano from the inside. Now there are two parts to a volcano. The volcano itself, which I thought these jello packs would be perfect for the volcano, and then the lava that breaks through the Earth's crust, which is hot liquid rock. So I got all of these things, which I thought might do a good job at representing that hot liquid rock. Now remember, we want to test these to find out which is just the right thickness to represent our hot liquid rock. It can't be too thick that it doesn't flow, and it can't be too runny that it just runs all over the place. So I think it's time to open them up, squeeze a little bit out, and see what their thickness is like. So if we look at all of these, I like how this Caro syrup is really holding its shape. I think it's going to be perfect for thickness. It's just clear. So now we need to figure out how can we make it so that we can actually see it. And I think what we need to do is add some food coloring. So we've decided on the Caro syrup for our hot liquid rock. Now it's time to figure out which Jello cup would work best for our volcano. These ones right here I think are a little too short for our volcano. I think it would work, but the taller it is, the better. So I have green and red. I'm thinking when I hold them up that the green is a whole lot easier to see through, so let's try going with the green. Now in a different aisle in the food store, I found this. Now I know it looks like a big needle, but it's not. It's called a flavor injector, and what I can do, it allows me to suck up all the flavored juices when I'm making a chicken, and then stick it inside the chicken and inject all those juices deep inside the chicken. And that's gonna work perfect because now I should be able to put all of our hot liquid rock inside my flavor injector and use it to inject that liquid rock into our volcano and see what happens. So let's take a little tour and get an idea of how this works. This comes with a sharp point, and what I had to do is snip that sharp point off so that I have one clean hole at the end. And then the top of this unscrews and it allows me to pull the whole plunger right out. And now I'm ready to dump my Caro syrup in. I like to put my finger over the hole. You don't really have to. Some will drip out. Now it's time to pour. I'll fill it not all the way up, about 2/3 of the way. It is clear, so now I have to add some black food coloring. Here we go. I want it to be nice and dark, so I'm going to put a decent amount in. Now it's time to mix it up. I'm going to use a nice skewer, which I'm going to need later for my volcano. Stir it around, and I have some nice dark liquid rock. So I have my hot liquid rock inside my injector ready to go. I have to keep it pointed up or it's going to leak out, so I'm going to set it in this glass. And now I need to get my volcano ready. This Jello pack has a plastic coating around it that I have to cut off with the scissors, and I can leave the foil covering on the bottom to keep things neat. I put down a tray to catch any juice. I'm going to take my scissors and snip the corner about that high. I start it, and what I like to do is lean the Jello down so I'm not cutting into the Jello. It comes away from the container as I turn it. I want to make sure it doesn't fall out. Trim it off, and I'm almost ready to go. And now I have my Jello volcano. So now it's time to take a closer look at what's going on inside our volcano. Our Jello's clear so we can really see what's going on. And now what I need to do is I need to put a hole through the center of my volcano. Scientists call that the main vent. And that's what the liquid rock travels through to get outside of the volcano. So I'm going to take my wooden skewer, center it as best I can, and now you can see me push through the Jello, creating my main vent, and I'm coming out the bottom. What I'm going to do is really make sure that vent is nice and open, by spinning my stick. And when I pull it out, it looks like it's almost gone. Well, that jello kind of went back together, but it's a weak spot, and that's really important. That hot liquid rock breaks through the crust where it's weak. So that main vent we just made weak. Now sometimes scientists have discovered that that hot liquid rock finds another weakness in the volcano and breaks through the side. They call that a side vent. So I'm gonna take my wooden skewer and make a side vent. I don't wanna go too far. I wanna meet up with the main vent, spin it. Now, my volcano has its areas of weakness. It's time to introduce the hot liquid rock and see which way it travels. So we're ready to make our mini volcano. I have my hot liquid rock in my injector. I have my volcano with the main vent and side vent. What I'm going to do is insert this into the bottom. We're gonna zoom in so you can see me insert this into the bottom, and then we can watch how the liquid rock travels up our volcano. We can see what's going on in the inside. So I'm gonna push this through the bottom. Now, I'll push this up too far so you can see the tip. There's the tip. I don't know if you can see it. I'm gonna bring it back down a little bit, and now I'm gonna be ready to go. So here we go. I'm gonna add some pressure with my hand to squirt the hot liquid rock up through my volcano, and let's see if we can watch how it travels. So you can see it start coming in. It broke through the main vent. Do you see the side vent coming out? It's gonna try to break through. It broke through the side vent. Now you can see I have a core of that hot liquid rock, a main chamber in my jello, that center magma. And as it breaks through, it's called lava. And you can see it oozing down out of my volcano, and we can clearly see the two main vents, just like the inside of a volcano. It was pretty cool to see how that hot liquid rock travels through the inside of a volcano. And all we had to do was visit our local food store.
Now that we understand what a volcano actually is, how do we go about predicting when one is going to erupt?
Well, like Jarrett said, volcanic eruptions are a result of pressure. This pressure does not only cause eruptions, but also causes cracks in the earth beneath the volcano, causing small earthquakes that can be measured by a device called a seismograph.
Typically, when a volcano is about to erupt, we will see an increase in these earthquakes, which is a strong sign that the area should be evacuated.
In this way, understanding the science behind these disasters allows us not only to better understand why they happen, but actually saves lives in the process.
Wow. Science is so cool.
Ain't it? I'm Haleigh.
I'm Adrian, and this has been Fun Science Network. Thank you for tuning in.
Science. Stop and try to wonder why.